This video focuses on piecewise functions. You will need some graph paper for this video. What we're going to graph is the function of a piece, and it's in 3 different pieces depending on the interval. So I've color-coded this graph, so you may want to pause this video. The first piece is when f of x equals 2x from 0 to a little less than 2. Then when f of x equals 4, between a little greater than 2 and a little less than 4. And the last piece of the function is negative 1/4 x plus 5 between 4 and 6. So this is our piecewise function. What I did is I separated out into 3 different pieces and we're going to graph those. So let's talk about the first function piece, f of x equals 2x. And I rewrote it so I replaced that f of x with the letter y. So that's a little more comfortable for students to look at. Y equals 2x. This is going to be a linear piece. So y equals 2x plus 0. The 2 represents the slope, and the 0 represents the y-intercept. And we're going to ignore the domain restrictions for right now, that interval or inequality. And let's graph that red piece. When we graph the red piece, we start with the y-intercept of 0, and then we're going to do our slope. Rise 2, run 1. Rise 2, run 1. And we'll continue that pattern for a while. So what we've created is a linear function over the entire domain, no restrictions at all. Now let's look at the restriction. The restriction set is between 0 and a little less than 2. So we're going to go on the x-axis, which is our horizontal axis. Here is 0, 1, 2. We want to keep everything between that interval. So I'm going to erase this piece right here because it is left of the domain. And I'm going to erase up here because it's also out of the domain. I'm going to go ahead and put an open circle here. So we're going from 0 to 2. We're just keeping that piece of the function. The next piece in the green, y equals 4. What this represents is the slope is 0, and the y-intercept is 4. So we have a horizontal line going through at 4. And we're going to ignore for right now the domain. So we're going to go on the y-axis. Here's 2, here's 4. This is my y-intercept. And I'm going to create that horizontal line all the way through. So I just created a graph y equals 4. Now let's take care of the domain restriction. We want to keep anything along the x-axis, that part of the graph, between 2 and 4. So we start now with 2, 3, 4. So we're going to keep the piece. Notice I'm erasing from 2 to 4, that little horizontal line. Our last piece is in purple, y equals negative 1/4 x plus 5. Our slope is negative 1/4. Our y-intercept is 5. Ignoring the interval inequality. So we go on the y-axis up to 5 units. There's 5, there's the y-intercept. We're going to go down 1 and right 4. Down 1 and then right 4. And we create that straight line. Now we look at the domain restriction. The domain is between 4 and 6. So 4, 5, 6 we want to keep. So we're going to keep this piece all the way down to that piece. Now we erase everything else. So what we have now, the red, the green, and the purple, that creates our piecewise function. If it asks us to evaluate it at f of 1, f of 5, and f of negative 1, we have to look at, I'm going to color these in blue, f of negative 1, 5, and 1. So we're going to go on the x-axis. This is the x, the x, the x. What would the y be? So we're going to start with f of 1. So here's 1. We're going to read up. What's that number on the y? Well, it is 2. Then we're going to go to 5. Read up. Just lost my smartboard. And it looks like it's a little less than 4, so we'll just say like 3.6. The last one at f of negative 1, the graph doesn't exist, so no answer possible there. And that's how you can graph a piecewise function or evaluate the piecewise function.